Okay, so today we will start the discussion of chapter 1, kinematics. This is the first chapter in the mechanics 3 book. Okay. Okay, so the first chapter, kinematics, is all about acceleration varying with time. Are you hearing this? Acceleration varying with time. Okay. So now, if you remember in M1 and M2, when you were working, we were working with constant acceleration. Basically, we had changing velocity, changing displacement, but our acceleration was constant. But over here, you can see that we are working with the first part of the lesson, 1.1 section. You talk about acceleration varying with time, or in other words, acceleration is a function of time. Okay, look. So you can use calculus for a particle moving in a straight line with acceleration that varies with time. So to find the velocity from the displacement, I think you are familiar with this section. Am I correct to say? To find the velocity from the displacement, you differentiate. I think you might have learned this in your IGCSE as well, where they give you the displacement with respect to time. So the displacement you differentiate, and what do you get? Displacement you differentiate, you get velocity. And velocity, when you differentiate, you get acceleration. So I think you are familiar with this part, right? This section. So to obtain the velocity from acceleration, you the other way then, to obtain the velocity from acceleration, when you go reverse, what do? Acceleration to velocity, we integrate. And again, from velocity, when you want to go back to displacement, you again have to integrate. Can you see? Because obviously differentiation and integration are reverse processes. So if you go from displacement to velocity to acceleration by differentiation, the other way is by integration. Do you agree with me? So they have given you here some important rules. So velocity v equal dx by dt. Does it make sense to you? Displacement is given as x. This differentiate displacement once and you get dx by dt, which is the velocity. Do you agree with me? And then velocity, if you differentiate once, dv by dt, you get the acceleration. Do you agree with me? Also, acceleration, we can also say it as where we differentiate displacement how many times? You differentiate the displacement once to get velocity. So if you differentiate displacement twice, you get the acceleration. Do you agree with me? D square x by dt square is another way of saying acceleration, because you differentiate once, you get velocity, and differentiating velocity again is giving you acceleration. Is that clear? So the first thing is, so these are the rules that they've given you. I think you are kind of familiar with these rules, right? And the other one, velocity, you obtain velocity when you integrate acceleration, and you obtain displacement when you integrate the velocity. So remember, all of these stuff is when it's a function of time, your displacement, your velocity, your acceleration, everything, when it's a function of time. Basically, the equation they give you is with respect to t. Okay. So this is section 1.1. Everywhere where all the functions, displacement, velocity, acceleration are all given with respect to t. Okay. So let's go for the question. And also here they have told you, watch out. Here, when you integrate, it is important that you remember to include a constant. You do remember when you integrate without limits, you must input a constant. So you include a constant of integration. Many questions include information that enables you to find the value of this constant. So obviously, if it's a question that requires you to integrate, they will give you some kind of a boundary condition to find that C. Okay, so let's actually go for some questions and see what they're talking about. Okay, I think then you can understand what's going on. So let's go to the first exercise, shall we? Okay, so we'll try to do these questions. Okay, so exercise 1A, question number 1. We'll start with this exercise 1A, question number 1. So let's read. A particle P is moving in a straight line. Initially means what? Normally in these kinds of questions, initially means at the beginning, right? At the beginning means when you consider the time factor, time is 0. Initially means time is 0. So initially, P is moving through a point O. O means, now remember, O, what we consider as O is like the origin, like the place where we have 0, 0, the point O. Okay, so initially means at time 0, your particle is moving through the origin with speed 4 meters per second. So these are kind of like boundary conditions. What have they given you? When time is 0, so write down the boundary conditions. When time is 0, displacement is what? You're at the point O, means now from point O only we measure the displacement. So at time 0, x is 0, and what about the velocity? At time 0, velocity is 4. Can you see? So these are like kind of like the boundary conditions at the beginning. These are the conditions. Okay. Then they say at time t seconds, after passing through O, the acceleration of P is, what is the acceleration? 3e to the power minus 0.25 t meters per second square. So do you see do you see something about this acceleration? You can clearly see your acceleration is a function of time. You can clearly see your acceleration is a function of time. So they're asking you, they say at time t seconds after passing through O, the acceleration of t is 3e to the power minus 0.25 t meter per second square in the direction OP. In the direction OP means what? O is the origin and P means you're going away from the origin. OP means you're going away. So they're asking you to find the velocity of the particle at time t seconds. Okay. So they're asking you to find the velocity. So acceleration to velocity. So if you refer this chart, you don't even need to refer the chart. But acceleration to velocity means, are we differentiating or are we integrating? Acceleration to velocity, we integrate. Acceleration to velocity, we integrate. So all I have to do here is what? I have to integrate this function. Do you agree with me? Okay, so let's integrate the acceleration to get the velocity. Are you guys with me? So now this is the place where you need to remember what? P3 integration. So you need to remember P3 integration with respect to T. So acceleration, when you integrate, we get velocity. Okay, what about the integration of e to the power minus 0.25 t? So if you go through the rules, can you remember the rules? So go through the P3 integration rules. You need to really know them and you need to really remember them. So I've taken the rules here. Can you remember these rules? So I have taken the P3 integration general rules are written here. So e to the power ax plus b, isn't it? E to the power ax plus b integration. You use rule number 2. It's going to be 1 over a e to the power ax plus b. Do you agree with me? So over here, how does the integration work? 3 is a constant. Let the 3 be there. E to the power minus 0.25 t. Here, the variable is t, not x. So anyway, the method works exactly the same. Here, a is the constant who is with the t. So what do you do? When you integrate, it's going to be 1 over the a value is minus 0.25. Yeah, a value here is minus 0.25 into e to the power minus 0.25 t. Do you agree with me? And then after you're done with the integration, what do you do? It is over. You have to remember to put a plus C. So I think they told you in the, it was clearly mentioned in the note also, right? So when you integrate, you must remember to put a plus C. Can you simplify this for me? 3 over minus 0.25, how much is it simplified? How much? Minus, right? Minus 12. 3 into 1 over minus 0.25 is minus 12, isn't it? E to the power minus 0.25 t plus c. So guys, can you see how this works? And now what? Are we done with they asked you to find the velocity. Have we completely found the velocity function yet? No, we have to also find what? The value of the unknown c. To find the unknown c, that's why they give you these boundary conditions at the beginning. So what are the conditions they've told you? At time 0, what should I use? At time 0, velocity is 4. So use that. So substitute the boundaries. Velocity 4 equal minus 12 e to the power minus 0. Actually, e to the power 0, right? E to the power minus 0.25 into 0 is e to the power 0. Plus c, e to the power 0. Any number to the power of 0 is 1. So 4 equals minus 12 plus c. So c is 4 plus 12 is 16. Guys, do you agree with me? So now replace the c value back into the equation and write velocity v equals minus 12 e to the power minus 0.25 t plus 16. Do you agree? So this is the velocity function, the answer for question number 1. Okay, so next I'll attempt question number 5. A particle P is moving along the x-axis. At time t seconds, the displacement of P from O is x meter and the velocity of P is 4 cos 3t. Okay, what have they given you? They have given you velocity as a function of time. Can you see? In question number 5, velocity is given as 4 cos 3t meters per second. Okay. Both measured in the direction OX. OX means it's measured away from the origin. Okay. So again, there are some important things here about these directions. So I think I will come talk to you about these directions in a moment. So actually, you need to remember that whenever we are moving, or it's supposed to be moving away from the origin. Okay, so when we are moving towards the origin, there's going to be a small addition that you have to do. We'll come to that at the later point. Okay, over here, the important thing is it's measured in the direction OX, which means away from the origin. When time is 0, so these are the boundary conditions. So when time is 0, the particle P is at the origin. So when time is 0, it's at the origin means what? When time is 0, particle is at the origin means what? X is equal to 0 because X is the displacement. You know, there are only 3 variables here: displacement, velocity, and acceleration, and also the time. 4 variables. Okay. So all you have to do is just look at the boundary conditions and write down. So they say when time is 0, the particle P is at the origin. They have not mentioned anything about the velocity though. So can we assume the velocity is 0? Have they told us anywhere that we can't assume it's 0? Okay. Unless they tell you at the origin it's at rest. They have not mentioned any such thing here. So do not assume velocity is 0. Got it? Okay. So at time 0, the particle is at the origin. Okay. Find the magnitude of the acceleration when t is pi over 12. Okay. How do I get the acceleration? Obviously, what is the principle when you go velocity to acceleration? Velocity to acceleration, we must differentiate. Velocity to acceleration, we must differentiate. So then let's go for the differentiation. Do you remember the differentiation principle? Cost differentiation, T3. How does it work? dv by dt. Let me write here dv by dt. 4 times cost differentiation is, can you remember? Cost differentiation is minus sine 3t. And are we done here? No, into 3d differentiation is 3. Do you agree with me? 4 times minus sine 3t times 3. So what do I get here? dv by dt, or in other words, dv by dt is the acceleration. Acceleration is minus 12 sine 3t. Acceleration is minus 12 sine 3t. Got it? So they ask you to find the magnitude of the acceleration when t is pi over 12. So what do you have to do? Replace t as pi over 12 into this equation and type in the calc, get the answer. So when t is pi over 12, substitute t is pi over 12. Acceleration equals minus 12 times sine 3t, 3 pi over 12. Do you agree with me? So we'll type, make sure the calculator is in what mode? Make sure the calculator is in radian mode. Minus 12 into sine 3 pi over 12. So it's minus 6 root 2. Do you agree with me with my answer? Acceleration is minus 6 root 2. Minus means because it's directed towards the origin. Normally a minus mark means it's towards the origin. Actually, that's what I want to tell you over here also. Away from the origin is positive. Towards the origin means negative. That's why you get a negative. Now the question they ask you to find what? The magnitude. So when they ask the magnitude, it means just give the size. So what is the magnitude of acceleration? Magnitude is simply 6 root 2 meter per second square actually, right? 6 root 2 meter per second square. Okay, yeah, once again, when you're moving away from the origin, the acceleration is, we consider it as positive. So over here, negative means actually your acceleration is directed towards the origin. So those are some things that you need to know. Okay, yeah, okay. So when it's if the acceleration is directed towards the origin, it's that's when you get the negative sign. A positive acceleration means the acceleration is directed away from the origin. Okay. Okay, so magnitude of the acceleration is just take the size of it without the sign. Okay, just take the size of it. Next part B, find x in terms of t. Okay, how do you get x in terms of t? X means the displacement. So how can I get the displacement in terms of t? Yes, what should we do? To get x in terms of t, we must integrate whom? The velocity. You know the rule that when you integrate, now when you differentiate velocity, you go to acceleration. The table was given to you clearly, right? Velocity when you differentiate, it was acceleration. But velocity when you integrate, you get the displacement. Can you remember in the table? So velocity integration is the displacement. So all you have to do here is take the velocity function part B. So velocity is equal to 4 cos 3t. So actually velocity, when you integrate, even if you want, you could even do it like this to show a little bit more, to make it more look better. You know, velocity is actually dx by dt, right? I told you velocity is equal to dx by dt. We wrote it, right? Did you write this down? These equations, because we wrote it down as a rule, isn't it? Here, these are some main rules that actually you should write it down. Velocity is dx by dt. Acceleration is dv by dt. So you need to point these things down. These are really important. Okay, velocity is dx by dt. Acceleration is dv by dt. That is when you are working with respect to time. Okay, in section 1.1 in this book, we are working with respect to time. Okay, so then what I'll do here is, okay, so instead of like directly just putting the integral sign, just going with the integration sign, okay, I will use velocity as dx by dt. And then what we can do is we can bring the dt to the other side. Okay, so look at this. So I'll bring the dt to the other side. So dx equals, what do I get here? 4 cos 3t and dt. Can you see? So this side, you have everything with respect to t. This side, you have everything with respect to x. And then what you can do is you can integrate both the sides, because you know anyway, when you are going from velocity to displacement, you are supposed to integrate. The rule was to integrate. So this side integration is going to happen with respect to x. The other side integration is going to happen with respect to t. This looks better. I mean, otherwise, I was about to perform the integration immediately. You could perform the integration immediately also and say integrating both sides. Velocity integration is displacement. You could do it like this. But instead of going like that, it would be better to, this looks better. Velocity is dx by dt. And then you keep dx here, take dt to the other side with the terms that have t in it. And then you apply the integration mark to both the sides. So over here, integration happens with respect to x. On the other side, the integration happens with respect to t. So over here, when you're integrating with respect to x, what do you have in the middle? There's nothing in the middle, means it's a 1. What happens when you integrate 1 with respect to x? You get x, right? When you integrate 1 with respect to x, it's x. The other side, can you integrate 4 cos 3t with respect to t? So with respect to t means just perform the normal integration. So can you all go through the rules? So I think I have the rules over here. Let's go for the cos integration. So how does the cos integration work? Yes. So I think it's rule number 4 here. Can you see how the cos integration works? Cos ax plus b, it's 1 over a sin ax plus b. Can you see? So 4 is a constant, let the 4 be there. Cos 3t. Instead of x, we have the t variable. So cos ax plus b is 1 over a sin ax plus b. So cos 3t, there's no plus part here, just the 3t. So just work with the cos ax part. So cos ax is 1 over a. So 1 over a is 1 over 3 sin 3t. That's all. There's no plus b part here. So just ignore it. 1 over 3 sin 3t. Do you agree with me? I'm done with the integration. And after I'm done with the integration, you must input plus c. You must input plus c, right? Because it's an integration. So I get here x equals 4 over 3 sin 3t plus c. Do you agree? And now is my integration, is my x equation complete? No, there's an unknown c. How do you get the unknown c? That's what they gave us these conditions at the beginning. They told you when time is 0, x is 0. This was given to us at the beginning of the question. Can you remember? This was given to us at the very beginning of the question. Okay, so let's use them. So when time is 0, x is 0. Let's input the limits. 0 equals 4 over 3 times sine 0 plus c. What happens? Sine 0 is, in radian mode, sine 0 is 0, right? Sine 0 is 0. So these are things that you need to remember. So I get 0 equals 4 over 3 into 0 is also a 0. Plus c. So I end up getting a c equals 0. Agreed? So let's input that back into our equation. The final equation is x equals 4 over 3 sine 3t. So this is the equation relating x and t. Is that clear? This is the equation relating x and t. Okay? And then we'll move to part C. Part C, they ask you the smallest positive value of t for which p is at O. What do you mean by p is at O? The smallest positive value of t for which p is at O. At O means the particle is at the origin. At the origin means what? What happens when you're at the origin? Your displacement is 0. When you're at the origin, the displacement is 0. So they ask the smallest positive t value, which means what? There are going to be multiple t values where you're going to be at the origin. So they want the smallest t value, which means you have some kind of an oscillating, system around the origin. Probably particle moves left, comes back, and maybe you have some kind of oscillating system. That's why you might you have come to this origin many times. So anyway, they ask you to find the smallest positive t value where the particle is at the origin. Okay, smallest positive one. Okay, how do we get it? Part C, I understand when I'm at the origin. What happens if I'm at O? X should be 0. Do you agree? Do you agree when I'm at the origin, X is 0? So let's input X as 0. 0 equals 4 over 3 sine 3t. Okay, so this is what? This is P2, trigonometry. Can you remember solving these kinds of equations? 4 over 3, you take it to the other side. 0 into 3 divided by 4. It's actually still 0, right? So you get here sine 3t equals 0. Can I know what are the angles that make sine 0? Ratio sine 0 is 0. If you remember the sine graph, or this is how the graph looks like. Sine 0 is 0. Sine, again pi is 0, right? And again sine 2 pi. So these are the values, right? For 3t. 3t is the angle here. So your angle 3t can be 0, or it can be pi. It can be 2 pi. You have many angles here. Do you agree with me? So t is going to be 0 divided by 3, pi divided by 3, 2 pi divided by 3, so on. So what is the smallest positive time figure I can get here? 0 divided by 3 is a 0, right? Oh, so what is the smallest positive t? Smallest positive t value is pi over 3. Is this clear? Can you see how this works? Okay. Question number 11. Okay, let's go to question number 11. A particle P is moving along a straight line when time 0. P is passing through a point A. Okay, so at time 0, it's passing through a point A. It's not at the origin though. Can you see? At time 0, can we say X is 0? No, because they say at time 0, particle is passing through a point A, which is definitely outside of the origin. So at time t seconds after passing through A, the velocity v of P is given by, so the velocity is given to you by e to the power 2t minus 11 e to the power t plus 15t. Find the values of t for which the acceleration is 0. Okay, so before you go to find the values of t for which acceleration is 0, what do you need to do first? First thing is you have to find the acceleration function because you have the velocity function. How do you go from the velocity function to acceleration function? What do? We should differentiate. So I gave you the table, velocity to acceleration, we differentiate. So how does the differentiation work? Velocity differentiation is dv by dt. Okay, remind me how to differentiate e to the power 2t again. E to the power 2t differentiation is e to the power 2t into 2, right? E to the power 2t into 2. This one, next one, minus 11 e to the power t differentiation is It's e to the power 1t, right? So it's the same. E to the power t differentiation is e to the power t. Plus 15t differentiation is plus 15. Do you agree with me? So dv by dt is a. Acceleration equals 2 e to the power 2t minus 11 e to the power t plus 15. Do you agree with me? So then they ask you to find what? Find the value of values of t for which acceleration is 0. So let's use acceleration as 0. I get 2 e to the power 2t minus 11 e to the power t plus 15. Okay, how do you go about solving this equation? Because they ask you to find the t value, which means you have to solve this equation and get the t values. How do I solve this equation? What kind of equation is this, by the way? This is a quadratic equation because e to the power t, then e to the power 2t. Like for example, e to the power t, we can say it's a. E to the power 2t will be a square. Do you agree with me? So it's a quadratic equation, and does it factorize? Can I know the factors? Equation, quadratic equation, ax square plus bx plus c. So 2x square minus 11x plus 15. So I get x1 equal 3. So here what does x stand for? Who do we use for x here? E to the power t, the lower power, e to the power t is the x here. So one factor is going to be e to the power t equals 3 means factor is e to the power t minus 3. E to the power t minus 3 is one factor. I hope you guys are okay with me doing this directly. Are you? The other one is e to the power t equals 5 over 2. If it's equal to 5 over 2, how do you make it the proper factor? Take 2 to the other side. So 2 e to the power t minus 5. Are you okay with this? These are techniques we use in P1. X equals 5 over 2 means 2x equals 5. So 2x minus 5. Okay, so these are the two values. So e to the power t minus 3 equals 0. Or 2e to the power t minus 5 equals 0. Making each of them to 0. E to the power t is 0 or e to the power t equals to 5 over 2. Do you agree with me? And then what? After this point, what did we do? What do? We need to make t the subject, right? Okay, so after you come to this point where you make e to the power t the subject, you need to make t the subject, right? So you could go from P2 methods, you could go maybe index form to log form. So if you have a to the power b equals c, the log form is log base a c equal b, right? Do you remember how this works? So using that, you can write here log base e 3 equals t. And the other one, log base e 5 over 2 equals t. So log base e means, you know, log base e, especially we use it for ln. Log base e is ln. So ln 3 is t or ln 5 over 2 equals to t. So these are your two t values. Leave it in exact form. So we normally leave our answers in exact form. This is okay. So ln 3 and ln 5 over 2. So these are the two t values. Got it? These are the two t values where the acceleration is 0. Okay, next part. The next part they say find the displacement of P from A when T is ln 3. Okay, you're supposed to find the displacement of P from A when T is ln 3. Remind me again, how do I go to the displacement? How do I go to the displacement? From I have the velocity function here. How do we go from velocity to displacement? We must integrate. Velocity to displacement is an integration. So let's integrate. Remind me the velocity function again. Velocity equals e to the power 2t minus 11 e to the power t plus 15t. This is the velocity function, right? This is the velocity function. Okay, so yeah. Okay. So let's go for the integration. So you know velocity is what I just showed you the previous time. Velocity is dx by dt. Shall I do in this method? Instead of directly integrating, I will write velocity as dx by dt and then do what? Take the dt term to the other side with the t to t function. So over here I'm remaining with dx. On the other side I have e to the power 2t minus 11 e to the power t plus 15t dt. Do you agree with me? Okay, so now what? Now we go for the integration. So this side, when you integrate with respect to x, 1 with respect to x, the answer is x. The answer is x. Equals e to the power 2t when you integrate. E to the power 2t over 2, half e to the power 2t, right? It's half e to the power 2t minus 11 e to the power t. Integration is e to the power t, right? Because you divide by the coefficient. Here we divide by 2 because it's 1 over a e to the power ax. That's how the rule worked, right? So I did not take the set of rules. Now I'm immediately using it. And the other one, 15t is going to be 15t square over 2. Are we done with the integration yet? No, after you're done with the integration, you must remember to put a plus c. So you must remember to put a plus c. Okay, now the thing is, how do we find the c value? Because to get the equation, they are asking us to find the displacement of p from a when t is ln3. So basically, I have used t as ln3 and get x, but I can't directly use t as ln3 until this, while this c is there over here. So I have to find the c value. How do I get the c value? How do I get the c value? I think they have given us some boundary conditions. They have told you when t is 0, p is passing through a, isn't it? And then they've told you at a. Now, when you are at a, the displacement of p, okay. We are supposed to find the displacement of p from a when t is ln3. Okay. So how do we get the c value? By the way, how do we get the c value? Yeah, actually, if you check here, they ask you to find the displacement of p from a, right? Not from anywhere else. Actually, over here also, when time is 0, particle p is passing through the point a. And they said that time t seconds after passing through a, the velocity v of p is given by this equation. So basically, they are asking you the displacement of p from a. So basically, from the place where we started, from the point a. So from the point a, what we'll have to do here is actually to do this sum. Actually, we need a little bit more assistance here. So actually, we'll have to go for point A as the origin, meaning we'll have to, in order to get the C value, you will have to use x is 0, t is 0 in order to get the C. Otherwise, we cannot proceed with the sum. Okay, because they want the displacement of P from A, meaning we have to assume that the displacement x is measured from A. Okay, because there are no other boundary conditions given here in order to do this sum. Okay. So when time is 0, p is passing through point A, they find the displacement of p from A. So we will have to use A as the origin in order to do this sum. Okay. I think that should have been mentioned. Okay, anyway. So I will use here when t is 0, x is 0 at A. So 0 equals half e to the power 0 minus 11 e to the power 0 plus 15 over 2 into 0 plus c. What do we get here? E to the power 0 is 1. E to the power 0 is 1. So this is a half into 1 is a half. 11 into 1 is 11. 15 over 2 into 0 is 0. Can I know how much is half minus 11? Or we'll take it like this. 11 plus 11 minus half is C. How much is plus 11 minus half? In fraction form? 21 over 2, right? C is 21 over 2. Do you agree with me? Okay. And then let's move on and input the values back to this equation again. So we get here x equals half e to the power 2t minus 11 e to the power t plus 15 over 2 times t square plus c is 21 over 2. Are you with me? Okay, so now I have found the complete equation describing x in terms of t. So I'm supposed to find the displacement when what? They're asking us to find the displacement when t is ln3. So let's use t as ln3. So when time is ln3, get the displacement, x equals half e to the power 2 ln3, 11 e to the power ln3 plus 15 over 2 t square is ln3 square plus 21 over 2. Are you all with me? So actually these values, I think there are some rules you should remember here. What are the rules? You should remember e to the power ln x is equal to x, meaning if you have e to the power ln 2, so for example, if you have e to the power ln 2, that's a 2, right? So these are some rules you need to know, okay? So e to the power ln x is directly x, e to the power ln 2 is 2, okay? So let's apply them. Okay, so I just wrote how this rule came into existence. I just showed here log base ex is, in other words, ln x, right? The same thing, log base ex and ln x are practically the same. And then what I did was I turned log form to index form. So e to the power ln x will be equal to x. Actually, that's how this rule comes into, that's how this rule has been created. So basically, if you have e without any number in front, if you have a ln, you can directly get the answer. Actually, you can see over here we have an issue because we have half e to the power. There's a 2 in front of the ln. So how you can't use this rule while there's a number in front. So that number, you can take it inside as a power by using the log rules in P3, in P2. So e to the power e to the power ln 3 to the power 2, because I'm taking this 2 inside. Can you see? This same 2 over here went in as a power because I'm just using the logarithms power rule. P2, P2 logarithms. Minus here 11. Over here, do I need to do any correction or is this okay at this point? This is already correct. E to the power ln 3 is directly going to be, using this rule, it's going to be 3. E to the power ln 3 is 3. 15 over 2 ln 3 square. Can I pull off anything off here? No, there's no power of e here. So ln 3 square will have to be directly ln 3 square. Don't go to, by the way, can I take this 2 in front as a, can I take the power 2 in front? No, because this, you can see here, this power 2, it's not, it's like ln 3, the whole thing to the power 2. It's not just the power 2 that belongs to a 3. If the power 2 belonged only to the 3, you could have brought it front. But this power 2 belongs to the entire ln function. That's why they have used a bracket around it. The bracket tells you that ln 3 is square, means it's ln 3 times another ln 3. Okay, it's ln 3 times another ln 3. 15 over 2 ln 3 square plus 21 over 2. Can you simplify here? What do I get? X equals half e to the power ln 3 square is e to the power ln 9. So e to the power ln 9 means, according to this rule, e to the power ln 9 will be directly 9. Do you agree with me? 11 times 3 is 33. 15 over 2 times ln 3 square plus 21 over 2. Can you simplify this in the cal? Half into 9. Half into 9 minus 33 plus 21 over 2. How much is it? Half into 9 minus 33 plus 21 over 2. How much? Minus 18. And then plus 15 over 2 ln 3 square. Okay. Okay, so I will now move to the 13th question in this lesson, in this exercise. Okay, a particle P moves on the positive x-axis. The velocity of P at time t seconds is 3t square minus 5t plus t meter per second, where t is greater than or equal 0. Okay, when time is 0, P is at the origin now. Clearly, they have said here what? In the 13th question, they have said time 0, particle is at the origin means x is 0. Okay, but have they told you that the velocity is 0? No, so we can't assume that. Okay, so the velocity is given to you. They are asking find the values of t when P is instantaneously at rest. What do you mean by instantaneously at rest? When you are at rest, what do you expect? At rest means what do you make equal to 0? Velocity, not displacement, not acceleration. You are at instantaneously at rest means your velocity is 0. Because velocity is what you talk about the movement. Velocity 0 means you completely stop. You come to a halt. So instantaneous rest. So instantaneous rest, you make your velocity, which is 3t square minus 5t plus 2. You make velocity to 0. 3t square minus 5t plus 2. So is it possible to factorize this particular quadratic equation? Does it factorize well? Yeah, can I know the factors? T minus 1 and 3t minus 2. So I end up getting t minus 1 is 0 or 3t minus 2 is 0. I end up getting t equals 1 or t equals 2 over 3. Okay. Then the next one. In the next part, we see here, find the acceleration of t when t is 5. How do you get the acceleration? Part B, how do you go for the acceleration? Velocity, you should differentiate. Differentiate velocity and you get acceleration. So when I differentiate, I get dv by dt equals 3t square differentiation is 6t minus 5t differentiation is 5. So this is the acceleration. 6t minus 5, and what do you have to do? You have to find the acceleration when t is 5. So input t is 5. Acceleration equals 6 times 5 minus 5, which is how much? 6 times 5 is 30 minus 5. Acceleration is 25 meter per second square. Is this clear? Moving on to part C. The total distance traveled by P in the interval between 0 to 5. When t equals 0, P is at the, sorry, this is for the part D. Part C, the total distance traveled by P in the interval 0 to 5. So in between 0 to 5 seconds, what's the total distance that you have traveled? Okay, so what's the total distance? How do you find the total distance that you travel? Okay, so basically stuff like this you have done even in M2 also, but this is quite easy. Now the thing here is, you can see in part A, we found two places where the particle comes to instantaneous rest, right? And basically, just look at this velocity time function. You can even make a quick sketch of your velocity time graph, right? Shall we make a quick sketch of the velocity time graph? The problem is they are asking us to find the distance. Now the thing is, now when they ask you to find the distance, you know, when you integrate velocity, are we getting distance or displacement? We get displacement. So there is a distinct difference between the words distance and displacement. Are you with me? Because they asked to get the total distance, not the displacement. Remember, when you integrate velocity, we get displacement. So what you do here is, let's draw a quick sketch of this velocity time graph, because I already know the places where it cuts the x-axis. Can you see the time values? Velocity becomes 0 at time 1 and time 2 over 3. Are you guys with me? So if I just draw a quick sketch of the graph, how does it come? 3t square minus 5t plus 2 is a what type of function? This is a what function? It's a quadratic. A plus 3 square means it's a quadratic minimum. So then you expect to see a graph like this, right? A quadratic minimum graph. Do you agree with me? So what are the cutting points? Cutting points are t2 over 3 and t is 1, right? Are you with me? You're supposed to draw the graph until 0 to 5. So until 5, we are supposed to go on until 5. So when you draw the graph, how does it come? At time 0, can I know the velocity? At time 0, what's the velocity? You replace t with 0. Can you see what happens when t is 0? When t is 0, velocity is 0 minus 0 plus 2. Can you see at time 0, your velocity is 2 meters per second, which means the graph starts at 2 over here. And then you draw a minimum graph that goes through these points. Do you agree with me? So you get something like this. Do you agree with me? You get a quadratic minimum graph that goes like this. So this is the velocity time graph. Now the thing here is this. You know, when you go for this integration, you know, you are actually integrating velocity to get displacement, right? So in P2, you have learned when you integrate a certain function, what are you actually getting? You get the area under the graph. So can you see here, when you integrate the velocity function, you get a certain area under the graph as a positive part. That's a positive displacement. Can you see between 2 over 3 and 1, you actually have a negative, I mean, when the area under the graph, when it's below the x-axis, it's a negative displacement. So which means this area is a negative area when you integrate. And again, this area is positive. Okay, so the thing what happens over here is this is positive, this is negative, this is positive. So all you have to do here is, you know, now normally I think you guys, what you would attempt to do is you would attempt to integrate the velocity you would attempt to integrate the velocity directly from 0 to 5. But if you integrate directly from 0 to 5, you get the plus minus plus and you get the minus part reduced. The thing is, I'm not supposed to get displacement, I'm supposed to find distance, which means all of these areas should be considered. Because this positive displacement means you're moving forward. A negative displacement means you're coming backwards. A positive displacement means you're again moving forward. So I have to add all these distances. Do you get it? So each part must be integrated separately. Integrate each part separately and add. Okay, so shall we integrate this each part separately? So integrating the velocity function, what is it? 3t square minus 5t plus 2, right? Each part integrated separately, 3t square minus 5t plus 2. So first you integrate this from where to where? The first integration, you can directly go for the integration limits. In this case, go for integration limits. Are you with me? Limits are from where to where? First limit is from 0 to 2 over 3. Do you agree with me? So this integration you need to perform, get the answer of that, and then you have to perform the integration of 3t square minus 5t plus 2 from 2 over 3 to 1. And then you have to also perform the same integration again for the limits what? For the limits between 1 to 5. Okay, so you have to perform the integration under all these three limits. So obviously here you'll get positive answers, here you'll get negative, here you'll get positive. To get the distance, ignore the negative sign and add everything. Okay. Yeah, this should be plus 2, right? Yeah, over here is the plus 2. Okay, let's perform the integration. How does it work? So it's gonna be 3t cube over 3 minus 5t square plus 2t, right? And then shall we apply the limits from 0 to 2 over 3? So from 0 to 2 over 3, what is the answer? 3 to 3 will cancel out. So I think the best thing to do here is to actually give this in the cal because you need to show the method. So we have done the integration. With the alpha, you can give x cube over 3 minus 5x square plus 2x. X cube over, sorry, there's no over 3, right? There is no over 3. It's just x cube minus 5x square plus 2x. T cube minus 5t square plus 2t. And then replace, because the first limit is you replace all the t values with 2 over 3. Isn't it? So you replace all the t values here. Calc. You solve for all the t values for 2 over 3. So we'll give all the t values as 2 over 3 and I get the answer minus 16 over 27. Is that okay? Yeah, this should be actually 5t square over 2, right? The integration 5t square, you should divide by 2 when you add 1 to the power plus 2t, right? Yeah, I think I've done this correctly now. Yeah, so in the cal, I should change the function as x cube minus 5x square over 2. Am I correct? Yeah. And now we'll give the x value as 2 over 3. I get the answer as 14 over 27. Is that correct? 14 over 27 when you give the first limit. 14 over 27 when you give t is 2 over 3 minus the second limit is when t is 0. I think when you give t is 0, you can directly see everything becomes 0. So the first part area under the graph is 14 over 27. Do you agree? The second part, let's get the area t cube minus 5t square over 2 plus 2t. What are the limits? Your limits are going to be from 2 over 3 to 1. Because the limits are from 2 over 3 to 1, right? Shall we first replace everything with 1? So in the first one, you replace everyone with 1. And I get the answer half. I get the answer half minus, let's input the second limit. Do you agree with what I just did here? I replace x with 1 and I get the answer half. Again, we replace the answer with 2 over 3. We should get the same answer as earlier, 14 over 27. So minus and the 14 over 27 because first limit minus the second limit answer. Half minus 14 over 27 is? Half minus 14 over 27 is? minus 1 over 54. Is that okay? Minus 1 over 54, the area under the graph or the displacement. So basically you're going behind. That's why you get a negative. Then again, we'll continue the thing t cube minus 5t square over 2 plus 2t integrating from 1 to 5. What do I get? First, we will replace all the t values with. First, I will replace all the t values with 5. What do I get? I get 10 minus, next I'll replace all the t values with 1. And I get minus 2. Is that correct? Calc when t is 1. Oh, sorry, 5 over 2. Sorry, I'm using the wrong equation. This one. Yeah, this equation. So, calc, I have to use t is first 5. The answer is 145 over 2. That's correct, right? 145 over 2. Calc, and then you replace x with 1, and I get minus half. 145 over 2 minus half. 145 over 2 minus half is 72. And now let's get the total distance. Because they ask you the word total distance, not displacement. If it was displacement, it's quite easy because in displacement, you would directly integrate from 0 to 5. You don't have to go through any of this trouble. Okay, because it's distance only, you have to do each part separately because we have a negative displacement part coming. So add everything together, you only take the magnitude. Do not take the negative signs. 14 over 27 plus 1 over 54 plus 72. Is that correct? So add everything. 14 over 27 plus 1 over 54 plus 72 equals 3917 over 54. Is this clear? This is how you get the answer. Okay. Okay, so then let's go to the next part. When t equals 0, p is at the origin O. Okay. So I think that was given to us at the beginning also. Show that p never returns to O. Explaining your reasoning. Okay, you have to show that p will never return to O. What do you mean by p never returns to O? So they have given you a hint also. In part B, form an expression for the displacement and show that displacement does not become 0 for any value of t except t is 0. Does that make sense to you? So if you want to show that this particle never returns back to the origin, it means now you have the displacement equation which we got. Did we get the displacement equation? No, we have to get it right. I think in part B, I was going for definite integration and with the area under the graph. I did not get the answer in terms of the proper equation for x. I did not find it. Shall we find the proper equation? How do you get the proper equation? Velocity equation was 3t square minus 5t plus 2, right? So when you integrate, I think I'll need a little bit more space. Part D velocity equation is, what was it once again? What was it? 3t square minus 5t plus 2. So when you, I'm trying to get the equation for displacement, which means I will integrate, right? So dx by dt equals 3t square minus 5t plus 2. So when I remove dt to the other side, 3t square minus 5t plus 2 with respect to t. And both sides we will integrate, isn't it? This side is dx, right? I'm sorry. Integrating this side dx, dt I remove to the other side. Do you agree with me? So when you integrate the one with respect to dx, what do you get? You get x, right? 3t square when you integrate, it's going to be 3t cube over 3 minus 5t square over 2 plus 2t, and don't forget the plus c because now I'm not putting any limits. And then to find the plus c, they actually give you these limits. What are the limits? When time is 0, particle is at the origin. So time 0, particle is at the origin means x is 0. So what do you get here? 0 equals 3 to 3 cancels. This is 0 minus 5 over 2 into 0 is 0. 2 into 0 is 0 plus c. What do you get for c? C is 0. So I get the displacement equation. X equals 3t cube over 3 means it's t cube minus 5 over 2 t square plus 2t plus 0. So this is my displacement equation. Now what do we need? What do I need to show? I have to show that the particle never returns back to the origin, which means I have to show that there are no t values that is capable of making this expression become equal to 0. There are no t values who can do that. Okay, so I have to do that. How do I do it? How do I show that there are no t values? Actually, in this equation, we can factorize the t out, right? Shall we take t out? Taking t out, what do I get? T square minus 5 over 2t plus 2. Actually, can you see I have a kind of like a expression now. Let me make x equal to 0 now. And then let's factorize. So I get t is 0 or t square minus 5 over 2t plus 2 equals 0. Can you see? T equals 0 was anyway given. At time 0, particle is at the origin is given. So other than time 0, you have to show that there are no other t values. Which means what? You have to show that this quadratic equation will what? Will not give you any roots. There are no t values. There are no roots for this quadratic equation that will actually make this equal to 0. So you can actually even check it from the calc quickly. So just to see whether we get roots or not, we just need to check whether we get roots or not. So 1 x square minus 5 over 2x plus 2. So what do I get? I think you can see I get roots in terms of I. Complex roots. Complex roots means there are no real roots. There are no real roots. So how do I show that there are no real roots? I can't just write it like those kinds of roots here. We show that there are no roots by using in a quadratic equation. To show that there are no roots, we go for the discriminant. Show that the discriminant is less than 0, negative. A negative discriminant means there are no real roots, which means there are no t values. So let's show the discriminant is 0. So you should get a negative discriminant because you don't get real roots. You should definitely get a negative discriminant. So going for the discriminant, b square minus 4ac, b square is minus 5 over 2 square. 4 into a is 1, c is 2. Can I know the answer of the discriminant? Minus 7 over 4, it's less than 0. So you can say discriminant is negative. I don't have space, that's why I'm writing over here. You write it down underneath, okay? Discriminant is negative, therefore what? Therefore, there are no real roots. There are no real roots. Therefore, the final conclusion means what? There are no t values. There are no t values that can make x 0. That means the particle will never return to the origin for any positive t values. Therefore, P never returns, right? P never returns to O for any positive t value. For any positive t value, because anyway you don't get negative t values. You only have positive time values, and for all positive time values, the particle will never return back to the origin. Is this clear?